Okay, gentlemen, so we are moving on to the next topic. The next topic is what are the type of pump we are using in cranes in the industry? Of course, this is a very challenging stuff. Too many types, too many makers, too many models, too much of fundamentals. But you have to grasp the basic fundamentals of the most popular types and so that you are in a better position to understand the working principle of the crane, because how the crane works depends on what type of pump you use, what type of a motor you use, hydraulic motor. So here you can see that I have a crane and I am going to reorganize my entire stuff by the pumps, what type of pumps, right? What type of pumps? By construction, by delivery, by the direction of flow, and then I'm going to give you examples, live examples of circuits which are from the ships. I'll give you live example, one each from two types of circuit. One is controlled hydraulically. This is now we have made a standard practice to see a crane which is controlled hydraulically and the crane which is controlled electronically. Electro-hydraulic crane with electronic control, electro-hydraulic crane with hydraulic control. You can see that electric crane is not there because obviously electric crane works with VHD motor, variable frequency VFD motor, sorry. Electric cranes work with VFD motors directly mounted to the rotating drum or the winch, whereas so obviously they don't have hydraulic pump. So you can see that the electronic crane column is missing.
Are your promotions slow? Not getting the respect that you deserve on board ship? If you are a marine engineer who is looking for faster promotions and earning respect on ship, then don't worry, Merchant Navy Decoded has your back. Introducing excellence packages for every rank now. You want to learn about purifiers, compressors, electronics, automation, MEGI engines, RT Flex, ME engines. Don't worry, we are there. Learn anytime, online, offline, whether you are on land or on board ship. Engineers who invest on upgrading themselves, they lead. What are you waiting for? Go to the description box and you will find different ranks, different excellence packages. Start investing now. Jai Mata.
So first one we'll see the most simple and popular type of pump, which is called the gear pump. So what is a gear pump? A gear pump is a pump where the pump is picking up some oil from a source or reservoir and that oil is thrown out or it is delivered. Now what is the uniqueness of this pump? This pump is always driven by a induction motor. Generally, let us take this case, induction motor. It's not always, sorry. The pump is driven by a, say in this case, an induction motor. Since the induction motor is going to work at a fixed RPM, we are not going to take that minor changes because of slip of the induction motor. Induction motor works at RPM which is decided by the frequency, correct or not? The hertz. Okay. So and the number of poles. So we have an induction motor. So let us say it's working at a particular RPM. Now I call this pump as a fixed delivery pump. Fixed delivery pump. Why? Because the RPM of the pump is fixed because it is depending on the induction motor. So as long as the number of poles and the frequency is fixed, the pump rotates at a fixed RPM. So my delivery rate, correct? Delivery rate is fixed. That means the pump says, the manual of the pump says, this pump is going to give you 100 liters per minute of oil. Correct? It will always give you 100 liters per minute of oil, whatever be the pressure. You cannot reduce it, you cannot increase it. Try to understand the characteristics of a gear pump. Right? Okay. Now, this is the favorite of most of the people. I have a axial piston pump. So I don't want to get into too much of a basic. I presume that most of you here are already crossed that level. If you are not, you are completely wondering what it is, then better come through the route of that hydraulic initial, what is that, fundamentals to hydraulics topic which is already there. So you come to that, there you'll get some exposure about the axial piston pump. So I am going to take you slightly up from that level. So I have a swash plate, but I am going to summarize it. Swash plate. Again, this is for the sake of understanding or for the sake of teaching. The real pump will be different, obviously, correct or not? So swash plate, right? So because of the tilt of the angle of the, because of the tilt of the swash plate, that means the swash plate has got tilted because of an angle. My pump is giving me a particular discharge rate is equal to Q is equal to, say, again let us keep this 100 liters per minute. And since this particular pump, what I am showing you here, it is driven by a motor, which is an induction motor. So the RPM of the motor cannot be changed. So what is happening is, this pump will always give me a delivery rate of 100 liters per minute. So I call it as a fixed delivery pump. Fixed delivery pump, but type of pump is a axial piston pump. It is not a gear pump. Axial piston pump, otherwise it is still a fixed delivery pump. Axial piston pump, it is still a fixed delivery pump. Why? Because I cannot change the angle of the swash plate. Cannot change the angle of, I cannot change the angle of the swash plate. Right? Okay. So I hope you understood this. Fixed delivery pump at a particular rate, it cannot change the angle of the swash plate. Right? So I move on to the next one. So let us move on and see the other option. A vane type of a pump. You see here, again driven by a fixed RPM motor, fixed RPM induction motor. This is the drive, correct or not? So the pump is again going to give me a rate of Q is equal to 100 liters per minute, which I cannot change because my RPM of the motor cannot change. So it is again a fixed delivery pump, but it is a vane type of a pump. What is a vane? You see here, taking suction from here and the delivery is from here, right? You can see, let us put another use. So this is the delivery, you see, when the veins are the thing, that from here it starts delivering back like this. You see here the X. So how do you understand what is suction, what is the delivery? Increasing volume along the direction of the rotation of the vane, increasing volume is equal to suction. You see, as the vane rotates, decreasing volume is equal to delivery, but it is a fixed delivery pump. Now we move on. This is like three types of pump: gear pump, axial piston pump, and fixed vane pump by construction. Now by delivery, sorry, we already talked about this, so we will not repeat it. The symbol of the pump, if you look at hydraulic symbols, which some of you have already done, if you are not done, so here it is, a fixed delivery pump. Fixed delivery pump. Now the symbol is not going to tell you whether it is a gear pump or a axial piston pump or it is a vane pump. All three of them are fixed delivery pumps. Symbol is going to be like this, but you don't know what pump is there by looking at the hydraulic symbol. But they are all, by delivery, they are all fixed delivery pumps. Understood? This also, in fact, we are repeating it, to be honest, correct or not? Now we are going to talk the other possibility in terms of delivery. You see, now I have created a possibility to change the change the angle of swash plate. You see, I have a mechanism. Let us write it here. I have a mechanism which is capable of changing the angle of the swash plate, and the drive is still fixed RPM, driven by a induction motor. Correct? Induction motor driving, RPM is fixed, but my angle of the swash plate can change, so my delivery rate can change. You see, when the swash plate is at this angle, so let us put it exactly where it is. Okay, this is my center line. Swash plate is at a 0 angle. Delivery rate Q is equal to 0 liters per minute. When the swash plate is at a maximum angle, correct? Q is equal to say 100 liters per minute. This is going to be controlled. What type of control? Again, we are going to have a subdivision of this to see what all type of controls are possible. But at the moment, if you look at it from a delivery point of view, we have a variable delivery pump. Obviously, it's a axial piston pump, so I have a variable delivery axial piston pump. Correct? Variable delivery axial piston pump. Right? Okay. So there we are. We can move on. The pressure to the stroke control pistons can be varied to attain different displacements with suitably designed control circuits. Just a small parting statement. Pressure to the stroke control piston here. If I manipulate the pressure here, correct? If I manipulate the pressure here, obviously I can manipulate the angle here. Correct? So obviously I can manipulate the delivery here because of this. Okay? Okay, done. Done. So we move on to the next variable delivery pump. Segregated the pumps. Initially we segregated by construction, gear, axial, vane. By delivery, I picked up an axial piston pump and showed you that axial piston pump can be fixed or variable. Correct? Gear pump cannot be variable. Correct? As long as you have an induction motor, gear pump is not variable. And vane pump can be made variable, but we are not going to show that here because it's not very popular, at least in cranes. Now by direction. So now let us look at the pumps from a direction point of view. Now all the pumps, axial piston, not axial piston, gear, right, axial piston, fixed, gear fixed, vane fixed, and I have a axial piston, but variable delivery. But you see, all of them can put oil only here by taking suction from here. So they are all called unidirectional pumps. Unidirectional pumps. It doesn't matter. I have this particular thing. They are all fixed, and this particular is variable. But all of them, they belong to the category of unidirectional pumps. Unidirectional pumps. Understood? So more or less you have understood. More or less you understood this particular angle. Okay. The next we move on to the bidirectional pumps. You see here? The symbol is now showing that this pump can take suction from here and put oil here onto the A side. So let us call this A side and this is the B side. It can also take suction from the A side and deliver to the B side. Both of them are possible. This pump. Correct? Both of them are possible. And what is the direction of rotation of the electric motor? Try to understand. The direction of rotation of electric motor is fixed. Correct? Without changing the direction of rotation of the electric motor, I am able to switch the pump from port A to B between suction and discharge, you see, by putting the angle of the swash plate. Now this is my zero position. If I go to the plus side, I am discharging it to the B port. If I am going to the minus side, correct, I am discharging it to the A port. You see, if the swash plate tilts to the plus side, now it is zero. If it tilts to the plus side, it is delivering here, and when the swash plate is tilted to the minus side, it is delivering here. Very important concept, gentlemen. This is what we are going to use extensively on a crane. Correct? We are using this extensively crane, but this concept is to be there. So what is the difference between the earlier one and fixed end one? Unidirectional, bidirectional. By the control point of view, the control is done by a double acting cylinder. You see, a piston, a control piston which has got double acting. I can put oil from here, or I can put oil from the other side also. Both sides I can put oil. So I am able to tilt the swash plate to the plus side or to the minus side and make it bidirectional. Now what type of controls do I have options? Look at this. This is that bidirectional axial piston pump. So you can see by the symbol what is giving you the let us, in case we have missed out on this point, you see here two arrows. It is telling you that I have a bidirectional pump, and this arrow, I make it in green, this arrow is telling that it is a variable delivery pump. This arrow tells me it is a variable delivery pump. These two arrows are telling me it's a bidirectional pump. And how am I going to get controlled? In this case, I have an entire system of control which is hydraulic control. Hydraulic control. Right? Okay, now other option is I have a control which is electronic. Same thing. Bidirectional pump, variable delivery, correct, double acting control unit, but the control unit is now electronic. That is the one which is going to do. How it is going to work, this is not the right module or topic for us to get into that depth, but that's also very important. But maybe in future modules, suppose you guys like it and want something more, obviously you have to comment and tell feedback. So this is not enough, we want to go more. Then probably we can come up with advanced version, right? But this is here we stop here. Now I am going to talk to you. I'm just going to show you some examples from a real life, right? Okay. Hydraulic control. You see, electro-hydraulic crane, hydraulic control. I am going to give you an example or show you an example. Then nothing much. We are not going to go into depth because, as I told you, this going into depth means we need to create a new module for each crane, right? Now I have a hose handling crane, hydraulically controlled. You see here, I have a motor which is, I have a pump which is a fixed delivery pump. You see, I have a pump which is a fixed delivery pump. Can you see this? By symbol, I know that this pump used on this is the fixed delivery pump. And the control of this pump, obviously a fixed delivery pump, there's nothing controlled. And so there's no point in talking about anything else. Fixed delivery pump, right? There's nothing to control here. Okay. And in hose handling crane, I am going to use fixed delivery pump. In that particular ship which I showed you, it is a axial piston pump which is fixed delivery. Now I am going to come to cargo cranes which can also use fixed delivery pumps. I am going to show you example of a cargo crane. What is this cargo crane? Mitsubishi. Okay, so Mitsubishi crane, you can see I have a pump, right, and I have a pump which is just a visual picture of that pump from the ship. But you can see that, of course, this pump has got one electric motor is driving 3 subunits, right? So, but you see all of them are showing you that they are fixed delivery pumps, correct? So we have a thing which is now a fixed delivery pump here, understand? Cargo crane, this is from a cargo crane. The earlier one was the hose handling crane. Now we are going to see some examples of circuits from a vessel which has got hydraulic control but variable delivery. You see here. Now what is this crane? It is a lever crane. You see, variable delivery pump but hydraulically controlled. Again, don't break your head. This is just to tell you that this is the possibility. Correct? This is just a possibility. So the scope of our module here is not to understand this. Okay, but I would advise that you prepare and make yourself more and more comfortable with hydraulic symbols and stuff like that, so that one day you will be able to understand what is happening here, and then you will be a better troubleshooter. So let me repeat the same sentence which I started the course yesterday. I said, if I am going to tell you today that you do this module and you will be a great troubleshooter, then I'll be lying outright. Nobody is going to be a troubleshooter just by understanding some basics. Yes, the motor itself is not turning, the pump coupling is broken, you found out, wow, the motor is turning, pump is not turning, you found the trouble, you are a great troubleshooter. If you are going to be happy with that, all the best, be very happy. I am not here to say you should not be happy. Yes, any trouble you solve is always cause for happiness. But what happens if the crane is not working because something here is not working, something here is not working? Understand? This is what I mean to say, that troubleshooting is, you cannot say that I am a great troubleshooter. Something here has gone wrong, something here has not moved. So my crane, are you in a position to understand what has gone wrong? Just think, right? Okay. Now, I don't want to feel guilty of discouraging the excitement you had. Yes, this is the fact. I am going to talk to you about another cargo crane which has got a variable delivery pump but electronic control. Now this is a cargo crane with electronic control. You see here. So I have a variable delivery pump, bidirectional, correct? Bidirectional, because I have these two arrows here, one arrow here, one arrow here, bidirectional. And this pump you can see here has got proportional coils. So it is electronically controlled. Electronically controlled. Okay. Who's the guy who's giving messages here? Multi-purpose card or PLC will be doing this job. So you see, electronically controlled pumps, right? So we are in the business of understanding pumps. So it is just a very common crane. If you ever go on a container ship, probably 70% chance that you will run across this. 70% chance, 50% chance that you will be running across these type of circuits. Very common. And to be honest, let me tell you, when I started off with this, I said I will never be able to understand this because nobody taught me. Oh my God, who the hell can understand what it is? But let me tell you, once you start understanding, it is very simple. These particular things are very simple. But that, you need effort from your side, you need the interest to learn. And if you are, this is more of a self-improvement, self-motivation, because, okay, when you have a problem, you are going to get stuck, you will be found wanting. But then maybe you have a 10-year career with very few problems and fuse gone here and there, but no big problems. You will feel like, no, wow, I am the guy running the ship. But maybe the truth is, you are lucky, so the ship ran, right? But you are not competent to solve those type of problems if they had come, right? So that's the truth. And even today, I will never say that I am a troubleshooter. No. Because I know what lies in store of this. I can always get a nasty surprise where I'm completely blank. I don't know what the hell is happening. I'll not be able to solve the problem. Right? I have seen service engineers coming and struggling for 2 days and then they don't know what is happening. So let us be very humble. Let us be down to earth and be aware of our limitations. And our goal is continuous self-improvement so that I can become better and better and better, but never arrogance that now I know everything. Okay. Let us stop our philosophy session here and get moving to the next topic.